Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you. And this is the data analytics and decision making course number 1 under the NPTEL MOOC series. And we are on the 24th lecture, as you can see. And this is a 12-week course for 30 hours. That's total number of lectures will be 60. Each week we have 5 lectures, each being of half an hour, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, in the last class, which was on the 23rd lecture, we were discussing about linear regression, multiple linear regression, the concepts and the ideas, what we mean by the assumptions being what is the error of the for the multivariate linear regression, then linear regression, what is the expected value of the error, what is the variance of the error, how the x's are dependent if there are more than one x, what is the relationship between the x's and the errors, what is the relationship between the how do you find out, I will not use the word relationship, how do you find out the variance of y given the variance of x and the variance of the error, how you find out the expected value of y given the mean value or the expected value of x and expected value of the error. And we also in the last part of the 23rd lecture we discussed that what we mean by rank, why rank is important, what is basically the concept of errors being independent, the concept of I just mentioned the words homoscedasticity and then heteroscedasticities, they would be coming up later. And we also discussed that given the n number of values for y's and n number of values of x's, considering there are k number of x's, we can predict the alpha hat, the beta 1 hat, beta 2 hat till beta k hat. Alpha may be there, may not be there depending on how the problem formulation has been done. And using those the estimated values or the hats, and they are based on the fact that you minimize the sum of the squares of the errors. And once these hats are found out, you basically plug them in the nth plus 1 value utilizing the x 1 to x k, that means x 1 comma n plus 1, that is the first value, the nth plus 1 value for the first variable till the nth plus 1 value for the kth variable. Utilizing that, you find out the estimated value of y n plus 1, and then utilize that value to basically to find out what is the error of the nth plus 1 term, that means the difference between y n plus 1, that is the actual value of y minus y hat of n plus 1. And technically if the errors are assumed with a mean value of 0, then if you have different errors from considering from n plus 1, n plus 2, n plus 3, so on and so forth, you can add them up, and obviously the expected value being 0, the sum of those errors should be 0 and the variance can be found out, and it should match with the value based on which we are proceeding. And now, another important thing which and I drew the graph also in a very simplistic sense, how the errors are there, in which directions errors are there, they can be positive errors, they can be negative errors and all these things. And for the multiple linear regression also we found out that given the mean values of x, I am just repeating it, given the mean values of x's and the mean value of the error, we can find out the mean value of y, given the standard deviation or the variance of x's and the standard deviation of the variance of the errors, we can find out the standard deviation or the variance of y. And obviously, when you consider the covariance matrix of all the x's and epsilon and alpha, you should remember that as alpha is a constant, hence its covariance with respect to other random variables will be 0, point 1. Point number 2, the relationship between the x's, that is xi and xj, as per the assumption is 0, they are independent, hence the covariances between two different x's I and j not being equal would be 0. And similarly, we also consider the covariance between the errors and the x's are also 0, hence those terms would vanish. So, only you will be left with the variances of all the x's and the variance of the errors, because the variance of alpha is not there. So, I will just repeat it. So, we should find out beta 1, beta 2 to beta k using the concept of minimizing the sum of the square of the errors. This is also known as the least square method, or method of ordering least square. The estimated we found out is basically beta 1 hat, beta 2 hat till beta k hat. They are the estimates of beta 1 to beta k, and they would have the properties. So, if you remember during the part where we were discussing about different type of point estimation, I did mention time and again the concept of unbiasedness and consistency. So, basically you find out the concept of unbiasedness and consistency for this beta 1 hat to beta k hat, and provided because you assume the underlying distributions for x's, epsilon and y's are all normal. So, we will utilize this estimate to find out the forecasted value of y, which is basically y hat or small y, whichever the notational concept you are using, and compare those with the actual values of y obtained, and then basically say something about the error. Now, we will consider something to do with, I will come to the problems later on. So, in general we will consider another area which is basically weighted moving average. So, weighted moving average is basically the concept where you give different weights to the past values, and based on the weights of the past values you try to basically predict the future values with least amount of error with respect to the actual value. So, this is not related to, definitely not multiple linear regression, because in multiple linear regression we consider that they are the y is dependent on the past data of independent variables considering x 1 to x k, but here you will basically try to find out the estimated or the actual and compare with the actual values of y respect to the past data of y only. So, in general a weighted k point moving average can be written. So, if you want to find out the k number of times of the moving average, you want to go back and find it out. So, it will be, you will take equal weights or equal distances from the positive and the negative sides. How you do that, I am going to come to that later. So, you will take the j values from minus m to plus m, that means you center your actual predicted value based on the weighted concept at the middle, and why we do at the middle, that will become very clear as I basically give the concept with respect to the histogram. So, you will give weights. So, the weights which will be given for the t minus m value would be a minus m. Similarly, the value which you will give to t minus m plus 1 value would be a m minus m plus 1, and go on till, say for example, the last value will be the value of would be y t m plus 1, all these are t m plus 1, t minus m or t minus m plus 1, all these are coming in the suffixes, and the corresponding weight would be basically be given by a m. So, what we are doing is, I will draw it. So, the values are, I will draw it vertically, so it will be easy for you to understand. So, the values are given. So, consider you have y t plus minus m. So, I am going in the downward direction. So, it is m minus m, space is less, minus m minus 1 y minus m dot till y m plus 1. So, I want to find out the middle value somewhere here. So, what I will do, I will give, for this obviously I am not taking any weights, because this is out of the purview, because the summation is being done from minus m to plus m. So, I will give a weight of a minus m, this is also not there. So, this would not come, I am putting a cross here, cross does not signify, it is basically not a variable or symbol, it is just a cross, it is not considered. I think I would utilize another color to give the cross. Let me use the blue one. This is a cross, this is also a cross. So, the value would be a plus m. So, you are basically summing it up. The sum when you do will be a minus m
y t minus m plus dot 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 dot, and that's like write the last value would be a m y t plus m.
So, if you consider the weights, technically further you go away from the actual value, like you are going more to the left or more to the right. That means, if I am standing here, I am going more to the back or to the front, the weights would basically diminish accordingly. So, if I consider the weights as some sort of histogram and I draw the histogram considering a different color and consider, I will use the highlighter with this color. So, for I will use this. So, the weight for the first one, that means minus m would be of this side, then m minus this one, sorry, then it will be this one. I will mark them what they are, then it will increase to this one, then again so it means if you are looking at this diagram and I am using the midpoints of the histogram, I have just inverted it. So, if I draw it, it will be a normal distribution. In the sense, the weight which you have here and the weight you will have here should be of the equal weightages. Hence, what you are trying to do actually do is that trying to give the weights in such a way that will basically form a normal distribution with the central value being the predicted or the estimated value using the moving average concept. Note the total weights. Okay, another thing, the total weights technically should all be 1. So, if I am basically adding up, I will use the different color. So, a minus m plus a minus m plus 1 plus dot dot dot. So, this is in the bracket a m minus 1 plus a m, this sum value should be 1. So, because it is a convex combination of the weights we are putting such that you are able to achieve your objective considering normal distribution is true and you find out the weights in such a way that they give you the best prediction. Weight should be symmetric. So, obviously, symmetricity what I have implied would be coming here. So, this part would be taken care as I have drawn using the histogram. So, this is basically a simple concept of moving average which we will take. Now, I will just give the rules. Rules are very simple, exactly what I mentioned, I will just highlight it. So, basically I will take these 3. So, I will take this one, the first one, second one and third one. So, the first 2 would basically lead to the third. So, let me start the concept using a different color. Okay. Now, consider you have values as y 1, y 2, y 3, y 4, y 5, y 6 and okay, we should have a y 7 also because it is a 4-year moving average 4 times. So, I should consider the 4th and the 5th also utilizing this. So, I will utilize the 1, 2, 3, 4, 5 in order to explain you this. So, I should basically redraw
So, this is y1, y2, 3, 4, 5, 6, 7. So, these are the difference. So, and basically highlight it with. So, this is the first. So, I am just drawing a division in order to make things easy. So, obviously, there would be more values, but I will take as given here. Now, what does 4MA1 mean? 4 means 4 months taken, for 4 time periods taken, MA means moving average, 1 means for the first instant. So, what I do is that I take the first one with 1/4 probability, because I am taking 4. So, if it is 3, it will be 1/3, it is 6, it will be 1/6. Second one with 1/3 probability, third one with 1/3 probability, fourth with 1/4 probability. So, addition of all the weights are 1.1. Point number 2, I am giving equal weightages now, but you will see later on, if you remember, it will be symmetric as I have drawn that normal distribution. For 4MA2, 4 month moving average for the second set of calculations, again I use a different color. Let me use the orange. So, now I am using 1/4 here, 1/4 here, 1/4 here and 1/4 here. That means, I am starting at y2 and ending at y5, not at y1 and ending at y4. So, I am just shifting by 1 notch. For 4MA3, I will basically start with 1/4 for y3, 1/4 for y4, 1/4 for y5, 1/4 for y6. So, this is 4MA3. 4MA4, again it will move 1 notch, it will be again 1/4 weights, and the weights would be given in this way. It will be 1/4 for y4, 1/4 for y5, 1/4 for y6, 1/4 for y7. So, obviously, if I find out the total probability for this would be, let me use the coloring scheme as black. So, it is easy for me. So, the total weights here would be, if I find out the whole weights. So, obviously, the weights in between for y4 with the highest. So, y4 would basically be, I am basically giving the ratio in those ratios. For y1 it will be 1/16, and for the last one it is also 1/16, that is 0.1. 0.2 for the y2 and y6, they would be 2/16, this is 2/16. For third and fifth it will be 3/16, 3/16, and the fourth one it will be 4/16. So, if you see the weights, this one and this one are equal, this one which is y2 and y6 are equal, y3 and y5 are equal, and similarly the middle one is the highest. So, if you look at this histogram and I draw it, so it is, I will draw the histogram, this is the baseline, I am just inverting it. So, 1/6 weight comes here, 2/6 would be little bit higher, 3/6 would be a little bit higher, 3 times. So, let me draw it the 3 times. 4/6 would be much higher. This is a proportional, may not be right diagram, but I am trying to basically highlight. Then the third one would be the third from the last would be again height of 3/6, second from the last is 2/6 and other value is 1/6. So, if I draw the histogram, it will be a normal distribution exactly as the values have been predicted. Now, if I do it say for example, for 3, so obviously the calculation will change. So, in the case first case it will be 1/3, 1/3, 1/3 for y1, y2, y3, again 1/3, 1/3, 1/3 for y2, y3, y4 and 1/3, 1/3, 1/3 for y3, y4, y5. Find out the weights and proceed accordingly. Just one thing, the weight should be exactly equal to 1. So, if you have 2 plus 1 3, 3 plus 3 6, 6 plus 4 10, 10 plus 3 13, 13 plus 2 is 15, 15 plus 1 is 16, 16 by 16 is 1. So, which basically corroborates the fact that the assumption what we have started with is true. Now, remember that this moving average concept, whether you are taking 4 month, 3 month, 5 month, 2 month, 7 month, whatever, it can be changed accordingly depending on what is the level of accuracy you want. So, in the case of 5 cross 4 cross 1, in the case of basically first case, what was 4 cross 4 was 4 month, you took it for 4 times and then you did the average. In 5 cross 4 cross 2, you will basically doing it the next stage in order to basically bring more normality in the case as the weights are more spread out and the sum of the weights is equal to 1, obviously that will be true. And you can do the calculations accordingly, put negative weights, positive weights such that the overall sum is 1 and it basically mimics weights would be symmetric, mimics the normal distribution. Now, we have the data given in the number in 10 to the power 5 of worldwide international airline passenger for the year 1949 to 1956. So, you have to use this data to find out the 3 month moving average, 5 month moving average, 7 month moving average, point 1. Then you find out 4 month moving range for 2 times, 6 month moving range for 2 times, that means you are trying to find out the average, 3 month moving average 3 times and 4 month moving average into 4 month moving average into 5 depending on the accuracy which you want. So, this is the data which you have from 1949 to 1956. The first columns which you have here as well as the third column as well as the fifth column as well as the seventh column. So, 1, 3, 5, 7 are the months and the corresponding values are the passengers 2nd, 4th, 6th and 8th. So, basically they start from 112 in January 1949 and end to 306 in December 1956. And you can do it. So, based on that you can find it out. So, if it is 3 months, 4 months, 6 months, you can do it accordingly. Now, exponential smoothing methods, I will come to one simple solution later on. So, exponential smoothing one parameter adaptive method, this is one method we will consider. Then the Hall's linear method which is suitable for trends and there is Hall-Winter method which is suitable for trends and seasonality, and the Pegel's classifications which also consider in some details later on. Now, in the single exponential smoothing method, what we have is basically you give weights to both the forecasted value as well as the the actual value from the past. So, consider that you have f t which is the forecasted value and y t is the actual value. So, what we will do is that if I am standing today in January, in say for example, January 2017, then I will use the predicted value as well as the actual value for December 2016 in order to predict the best, and obviously I will give weights accordingly. So, if it is f t plus 1, that means for t plus 1 at t period the forecasting is being done, it will basically give
weights or will be utilized depending on the forecast for the tth period, 1 period back, and the error of 1 period back. That means, you are giving weights accordingly to the actual value, which is y t, and the predicted value, which is f t. So, in that case, what you have, you are giving a weight of alpha to the actual value for time period t, and 1 minus alpha, because the sum of the weights is equal to 1, to the value of the predicted value 1 period past. So, what you have is actually like this. So, you have y, you have f. So, you have 1, 1. I am just writing the time period 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So, if you are basically trying to predict for the seventh time period. So, obviously, the actual has not arrived yet for y 7. So, you are trying to basically utilize 1, 2, 3, 4, 5, 6 data points for the 6 time periods using the y and f to predict f for the 7th period. So, when you are trying to do that, you will try to utilize the actual and the predicted for the 6th time period, which is, so you give a weight, it can be anything, it can be alpha 1 minus alpha or 1 minus alpha alpha, it does not matter. So, you give a weight of alpha here, give a weight of 1 minus alpha here, so that the sum is equal to 1, or it could be basically 1 minus alpha here, so that the sum is equal to 1. Now, the question would arise that can I go more back, that means, rather than 6th period, can I go into 7th period, can I go into can I go into 5th period, can I go into 4th period? Answer is yes. So, more back you go, you are trying to basically utilize the information from the past in order to predict for the future. So, here the error terms is y t minus f t, which is basically epsilon as we write. The forecasted value is y t, the actual value is forecasted value f t, actual value is y t. Weights are given between 0 1 inclusive, and alpha is such that the sum of the squares is minimized. So, what we are actually trying to do is that for the 7th period. So, I will just write the period number 7th, 8th, 9th, 10th. So, you basically find out epsilon 7, epsilon 8, epsilon 9, epsilon 10, go on, such that you square the errors, sum them up, it should basically be minimum. In this case, when you are trying to basically minimum, you will ask the question what is there not known, it is alpha. So, you will basically, in order to do that, you will minimize with respect to the, so consider this is delta, you minimize that, put this 0 and solve the problems accordingly. So, with this I will end in the 24th lecture and continue the discussion in the 25th and so on and so forth. Have a nice day and thank you very much for your attention.